Okay, welcome if you are watching. This is a problem number 2 from our Webassign problem deck. The problem says the following. Roll 2 dice. Roll 2 fair dice, right? These are dice that are balanced and will come out the right way each time. And let event A be the event that we roll a 3 or 4 first, followed by an even number. And then we're going to let B be the event that the sum of the 2 rolls is at most 7. Well, what do we want to do? Our first problem right here is to list the sample space. Well, the sample space isn't that hard. All we're looking to do is look at what are the possible rolls, right? When we say what is the sample space, we're saying, well, what are all of the possibilities that could happen? And when you roll 2 dice, of course, you know that we could roll anything from a 1 to a 6 on any single dice. And so when we look at the possible combinations here, all we're really looking to do is choose the ones that are actually possible. For example, we could never roll a 7, but we could sure roll a 6. 3s are good, 5s are good, 6s are goods, right? All of those things are good. The only ones that we have to avoid are anything that has either a 0 or a 7 or something like that. So you see there's lots of choices right here. We can't get a 0 there. That's bad. No, right? See, we can only choose the dice that would make our situation correct right here. So we're looking for any of these guys that we could potentially roll. And if we go back to our illustration, what I've done right here is I've actually drawn this out. So imagine that the first dice is black, the second dice is red, and so if I look at my possible combinations, you see that, well, anything that looks like one of these, and there's 36 total combinations, right? 6 times 6 combinations that could make this true. And so we should have a total of 36 possible outcomes here as well. So being careful to avoid the impossible situations, we mark those. So we ask the question, well, what is the probability of event A? Okay, so let's go back. Event A says that we roll a 3 or a 4 first, followed by an even number. So if our first dice is A right here, if our first dice is A, let's go ahead and circle that. If our first dice is a 3 or a 4, followed by an even number, that means that we're looking at the following combinations, right? Probably should have reversed that, but okay. So we're saying that that second dice in black comes first. I know that's a little weird to look at here. So we roll a 3 or a 4 followed by an even number here. So there's 1, 2, 3, 4, 5, 6 of those possible combinations. Out of a total of 36, right? So the probability of event A itself occurring is going to be 6 out of 36. And we should reduce that every single time you get a fraction. You should reduce it completely. 6 out of 36 divides by 6 in both the numerator and denominator to give us 1/6. So that's our probability for part A. Well, how about the probability for part B? That's a little bit more interesting. It says B is the event that the sum of the 2 dice rolls is at most 7. So let's see what could give us 7. Well, any combination that's less than 7 fits right here, right? 1 and 1, 2 and 1, 3 and 1, 4 and 1, right? All of these guys add up to 7. But now we have to avoid 6 and 2. But 5 and 2 is good. And you see what's going to happen right here is if you follow it along, our combinations go in sort of a triangular pattern right here. We end at 4, 3 right there, and then 3, 4, 2, 4, 1, 4, right? 2, 5, and 1, 5, and then 1, 6, right? These are all combinations that I've just highlighted right here that are combinations that are less than 7. And if you actually trace that out, that looks an awful lot like a little stair-step pattern right here that we have to stay above in order to have a sum that is at least or at most 7, right? So anything above that red little snaky line there, that's a 7. All right, so that's pretty good. So let's see. So probability of event B. What's probability of event B? Well, it looks like that we've got 6 plus 5, 11, plus 4, that's 15, plus 3, that's 18, plus 2 more, that's 20, that's 21. We've got 21 out of a total of 36. Now, of course, dividing by 3, I think both of those are divisible by 3, we get 7 out of 12. So our probability of event B is 7/12. 7/12 as a fraction. Okay, so let's see how we're doing so far as Webassign is concerned. So we're saying that our probability here is 1 out of 6. And probability of event B, we said, was 7 out of 12. So far, so good. How about part D? What is the let's see what probability of A given B. Well, okay, A given B. That means that we want the event of the dice to be 3 or 4 rolled first, followed by an even number, given that given B, right? So given probability of A given B is the event A, given that the sum is at most 7. Well, that's an interesting one. But let's see. So probability of A represents the probability of rolling 3 or 4 in the first die, followed by an even number, given that the sum is at most 7. That's that first one right there. What is our probability of A and B? Well, now this is where that little drawing that we made comes in handy. Which ones of these guys are the ones that we want? Well, it looks like a roll of a 3 followed by a 2, or a roll of a 3 followed by a 4, and a roll of a 4 followed by a 2, right? That's it. There's 3, and we have a total of 21 events, right? So 3 out of those 21 events represents the probability of A given B. Probability of A given that B has occurred, given that we've rolled something less than 7. Well, we have 3 outcomes that fit that out of a total of 21 of those possible outcomes, which is going to reduce to 1/7. Ooh, interesting. Okay, so let's go back to Webassign right here. So we should have 1 out of 7. What's part E say? Well, if A and B are A and B mutually exclusive events, right? Well, what does that mean, mutually exclusive? Well, let's go back to our slide set here. And it says the following about mutually exclusive events. We say 2 events, A and B, are mutually exclusive if the occurrence of one means that there can be no occurrence of the other. And if A or B are not mutually exclusive, they're conditional. So, okay, if rolling a 3 or a 4, followed by an even, were mutually exclusive with rolling something less than 7, we would have no occurrences then of rolling a dice that was less than 7. Well, that's not true at all, right? So our events are not mutually exclusive, right? Rolling a 4, let's see, rolling a 4 or a 6 is an outcome in event A, but not in event B. No, the events are not mutually exclusive because rolling a 3 or a 2 is an outcome in event A, and also an outcome in event B. That's our choice right there, right? We say, well, okay, what about are A and B independent events? Well, clearly not, right? Because one could affect the other, right? So they're not independent events, but what could we say? Well, events A and B are dependent because they have outcomes in common, or because A and B are dependent because the probability of A happening is affected by whether or not event B has happened. Well, event B does not, event B, let's see, event A happening is affected by whether event B has occurred. No, well, they do have outcomes in common. Let's go with that. So there we go. All right, so there's our answer. It's pretty straightforward, but we have to understand what that compound probability A given B means.